Hey guys, welcome to lesson 1.5. Today we're going to talk about our final topic for our function unit, which is piecewise function. We're going to talk about how do I evaluate and graph a piecewise function. So, the first thing, let's get into what is a piecewise function. So, definition. Piecewise function is a function defined by two or more functions over a specified domain. What do piecewise function look like? So this is a typical piecewise function. Notice that it's called f of x, and this is what I mean by specified domain. So anything x is less than 0, we're going to use this function, x squared plus 1. When x is greater than or equal to 0, it will be x minus 1. So with this function, you can evaluate a piecewise function and you can also graph piecewise functions. So this is our goal for today. How do we evaluate these piecewise functions and how do we graph them? So first thing, how do we evaluate piecewise functions? Evaluating a piecewise function is just like evaluating a regular function that you're already familiar with. Remember the f of 6 where you plug in 6 wherever you see x? Similar, identical to that. So let's calculate f of 2. So I have this function which we talked about earlier, and I want to find what's f of 2. So I need to look at the restriction. For this here, it says x is less than 0. And then the second part says x is greater than or equal to 0. So since I'm looking for f of 2, we are going to use this function. So you're being asked to find y when x is 2. Since 2 is greater than 0, you will only substitute that into the second part of the equation. So I don't care about when x is less than 0. I want to find f of 2, and 2 is greater than 0, so I'll just substitute it into our second equation. If I substitute it into our second equation, I'll get f of 2 is equal to 2 minus 1, which is 1. So it's identical to what we did before, guys. You just need to know which function. Now I'm having two separate functions. I need to know which one I need to plug it into. So if I had said let's find f of negative 2 in that same function, what do you guys think? Will I use x squared plus 1 or x minus 1? Where does x equals negative 2 fall under? Would it be less than 0 or greater than or equal to 0? So now, since x equals negative 2 and negative 2 is less than 0, we're going to use the first part, correct? X squared plus negative 1. So f of negative 2 becomes negative 2 squared plus 1, which is 5. Negative 2 squared is 4. 4 plus 1 is 5. Your turn. You're given this function, f of x is equal to 2x plus 1 when x is less than 1. 2x plus 2 when x is greater than or equal to 0. Evaluate the following. Pause the video and calculate these. Hope you guys got a chance to try these. So the first thing you got to do is determine which function you're going to use. F of negative 2, does it fall into our first function or second function? X is equal to negative 2. So we know negative 2 is less than 0, so I will use the first function. If I was to plug in negative 2 into my first equation right here, you should get negative 3. Now let's see what 5 look like. F of 5. Of course, 5 is greater than 0. I'm going to use my second function. So 2 times 5 is 10 plus 2. You should get 12. Now be careful. This one's a little tricky. It says f of 0. Both of these have 0, but remember, f of 0 is when x is greater than or equal to perfect. So you're going to plug in 0 into our second equation. So 2 times 0 is 0 plus 2 will give you 2. And then the last one, f of 1. Again, 1 is greater than 0, so I'm going to use my second function. 2 times 1 is 2, plus 2 is 4. Good job. Now let's try one more. This one now, we have f of x is equal to 3x minus 2 when x is less than negative 2, or negative x when x is greater than or equal to -2 or x is less than 1. And when x is greater than 1, our function is x squared minus 7x. So, try these on your own. Pause the video, let me know what you get. Great. Now that you try these, let's see. F of -2. First of all, the first thing is which function am I going to use? Function 1, 2, or 3? I know f is equal to -2, so that will be my middle function, which is -x. So negative parentheses -2 will give me a +2. Good job. What about the second one, f of 3? F of 3 means x is equal to 3. So which one of these domain, this restricted domain here, am I going to look at? I'm going to look at the last one. Perfect, because the last one said x is greater than or equal to 1. So 3 squared is 9. 9 take away 27, you get -18. Alright, 2 more to go. F of -4. So -4 we all know is less than -2, so we're going to use the first function. So 3 times -4 is -12, minus 2 is -14. Last one, f of 1. Hey, we know that's the third part of it because it says x is greater than or equal to 1. So 1 squared is 1 minus 7 times 1 should give us -6. The key thing to remember, guys, when you're evaluating a function, you need to find which domain, which part of this piecewise function does it fall in, and then just plug in, replace your value for x. Now graphing a piecewise function. I have this function, f of x is x squared plus 1 when x is less than 0, and x minus 1 when x is greater than 0. So the first thing you got to do is determine what shape is this graph. We know the first one is x squared, which is going to automatically give us a parabola. It's a quadratic. And then the second one, it's a line. It's a straight line. Okay? Now, so we have to look at the boundaries, meaning what is the value here? So this is a parabola when x is less than 0. So x is less than 0 is everything on this side, quadrant 2 and 3. And x is greater than 0 is in quadrant 1 and 4. Okay? So that's my boundary, the dotted line. So graph the parabola where x is less than 0. So I know my parabola. If I was to graph this, put it in your calculator, go to y equal x squared plus 1. My parabola looks something like this in green. But remember, it's x is less than 0, so I want only in the second and third quadrant. So I'm going to get rid of this piece right here because that's not in my what I need. Notice it's an open circle because it's just less than. Let's look at x minus 1 for where x is greater than or equal to 0. So I know it's going to be somewhere in these two quadrants over here. Quadrant 1 and quadrant 4. So let's graph the line where x is greater than or equal to 0. So if you were to graph a line on the calculator, again guys, use your TI Inspire, go to y equal x minus 1. Notice this is what you get on your calculator, but we're looking at this part where x is greater than or equal to 0. So it's where this red line is, everything in quadrant 1 and 4. So I need to get rid of or chop this piece off that's in quadrant 3. Take that off, and notice I started with a shaded circle because x is greater than or equal to. I just got rid of my boundary line, so that's what your piecewise function should look like. So, moving along, we have one more. This was this 3x plus 2 when x is less than -2, or -x when x is between -1 and +1, and then x squared minus 2 when x is greater than 1. So, remember, first thing, what shape does this look like? The first one I know is a straight line. It's in y equals mx plus b. Second one is a straight line. It's just -x. And then the third one, you see x squared, we know that's a parabola. So, we have two lines and a parabola. So, boundaries. We have some boundaries, -2, -2, and 1. So I'm going to draw just those two lines. Let's graph our first one, 3x plus 2. And remember, we want this. This is our first graph when x is less than -2. How do I know this is what it looks like in blue? Because I graphed it on my calculator. I know my y-intercept is a +2 and my x is up 3 over 1. But I want it when x is less than -2, so that will be everything to the left of this line right here. So I'm going to get rid of the rest. Notice it's an open circle again because it's just less than. I have negative x, and that's between -2, which is right here, and 1. So it will be somewhere in this piece right here. If I was to graph negative x, it will look something like that in purple. But remember, I only want it between these two dotted lines, so I'm going to get rid of the rest. This part of it is shaded because it says x is greater than -2. However, x has to be less than -1, so that's an open circle. You got to be very careful. When do I use open? When do I use closed? And the last one, remember we said we're going to get a parabola? So if I go graph this into y equal, I will get a parabola that looks something like that in green. But I want this when x is greater than 1, which is everything on this side, on the left of my second line. So I need to get rid of all of this, and I'm going to chop those off. I kept a shaded circle because it says x is greater than or equal. Is that possible for both of these to be at the same point? Of course. Then I'm just going to get rid of my boundaries, and just like that, that's my piecewise function. Piecewise function is just like different functions at specific restricted points. So what you're going to do is work on portfolio 1.5. Remember, complete it with a partner at your desk. That's fine with me. Noise level has to be at a 1. Check it with me or Miss Ewing if you're not sure on how to graph these or enter these on your calculator. Alrighty guys, see ya!